Hi again, everyone. Chris Tisdell here again. Thanks for tuning in. In this presentation, I'm going to continue my live streams of calculus for beginners. Now, in particular, we're going to talk about an example that shows you how to solve an inequality using a graph. So, here is the problem here. That it's a two-part problem. The first part is to sketch the graph of this function. Okay, so you've got a quadratic function, x squared plus x minus 12. And the second part says solve this inequality for x. So find the x values that make this inequality hold. Okay, so we're going to go through it. It's not a particularly difficult problem, but you can use the ideas in this problem to solve lots of other problems. Okay, all right, so first of all, let's look at the graph. Okay, so this is a quadratic function. The coefficient, the number in front of the x squared, is positive, so the quadratic function will look like a u rather than an n, okay? If we factorize this and set it equal to 0, we can find the x-intercepts, so they're the points where the graph cuts the x-axis. And if we plug in x equals 0, we find the y-intercept. So let's do that. It's got to look like a u, and let's find the x-intercept. So if I factorize this, I want two numbers that multiply to give negative 12 and add to give positive 1. Okay, so that would be 4 and negative 3. So I can factorize that into this form. Okay, all right, so the first thing, let me just write down what I just said. The first thing is that the graph is a parabola, and it's U-shaped because of the positive 1, or the positive number in front of the x squared. Okay, so the x-intercepts occur when the function is 0. Okay, now we factorize this because if we have the product of two things and we solve for 0, one or both of those things are 0, right? So x plus 4 is 0 and x minus 3 equals 0. Okay, so we solve this for the x-intercepts. So this expression is 0 when this is 0 or when this is 0. Okay. So x plus 4 equals 0, well, that just means x equals minus 4. Or x minus 3 equals 0. That means that x equals 3. So these are your two x-intercepts. All right, so we've worked out there's a parabola, it's U-shaped, these are the x-intercepts, and lastly, let's look at the y-intercept. Where does the graph cut the vertical y-axis? So to do that, let's consider f of 0. So if I go up here, I plug in x equals 0, that'll be 0. That'll be 0, and I'll be left with negative 12. All right, so y-intercept is negative 12. Okay, so let's actually draw it now. If I draw my axes in like that, I'm going to go through negative 12 there. I'm going to go through, say, negative 4 there. And I'm going to go through 3, say, there. Okay? So here's the y-axis, here's the x-axis, and all I've got to do is sketch that out. Okay, now it might not look exactly like that, but that's just a rough sketch. That's good enough for what we want to do with it. Okay, so that's the first part of the problem done. Okay, now part 2. All right, so the second part is hence solve this inequality here. Okay, hence means with what we just did. We just sketched the graph, and with that graph, solve this inequality. Okay, so x squared plus x minus 12 is greater than or equal to 0. So that means that we want to look at the graph and see where does it lie on or above the x-axis, because we want it to be greater than or equal to 0. So let's go to our graph and see where are all the points that lie on or above the x-axis. Okay, and if I look carefully, I'll go, well, it's all these points here and these points here. And what are the corresponding x points? So if I take my green pen and I match these up, it'll be all these points here and all these points here, but not these points down here. Okay, so that corresponds to all the points that are, or the numbers that are less than or equal to 4 or greater than or equal to 3. So let's write that down. So we're at the last part now. From the graph, x squared plus x minus 12 is greater than or equal to 0 when x is less than or equal to negative 4 or when x is greater than or equal to 3. All right. Now, in interval notation, the solution or the solution set okay, so let's write this as an interval. So it'll be you go off to negative infinity and up to 4, and you include 4. So I've got the square bracket. Or, so that's like a little u here, 3 and above. So you would write something like that. Okay, so this is probably a little bit simpler. This is just talking about intervals. Okay, and this is like the symbol for or, if you like. It's not and, because the two intervals don't intersect. Okay, so that's how we did it. Let me just step through that once again. We were given a quadratic, we factorized it. We realized the graph was a U-shaped parabola. We found the x-intercepts, we found the y-intercept, and we drew our graph. Once we had our graph, we could look where are the points on the graph above the x-axis or on the x-axis and match those with points on the x-axis. So we came up with this simple way of writing it and then writing it as the union of two intervals. Okay. What do you think, guys? Hope you enjoyed this video. If you have questions or suggestions, I'd love to hear them. Now, for this idea, the method scale, so if you had a cubic equation, you could factorize that and go through the same steps. It's a little bit harder, though. Thanks for watching, everyone. I'll see you soon. Bye.